Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 30 of Physics 5054, and today we are going to start a new unit, a new topic, that is work, energy and power. Uh, in this unit, we shall look at the basic concept of work and three related physical quantities, that is work, energy and power. First, we will give a look to work, and I am quite sure that you are familiar with this word in your daily life. But from physics point of view, work is having another special meaning. We will discuss that in this unit as well. Then we will turn our focus to energy, and in the energy I will give you the concept of five basics rules related to energy. While studying this chapter, you have to keep in mind these five aspects in view. The first one is energy brings about changes in the world. Yes, it is very much true. The second, we will discuss that in greater detail. Energy can be transferred from one place to another place. You have to keep this in mind. The third aspect is energy can be converted from one form to another form. Yes, this is also very much true, and we will take time on it to explain it. While studying this topic, you have to keep these things in mind. In energy conservation, total energy does not change. This is another aspect of energy. Some form of energies are more useful than others. We will discuss these concepts in greater detail. In fact, we will study different types of energies, and then you will decide that which energy is more useful than the other energy. So let's jump directly to the concept of work. In this chapter, the name applies that work is the first topic. So we are dealing work first as well, and the concept of work. As I told you at the beginning of this lecture, that the meaning of work in our daily lives and the meaning of work in physics is totally different. Let us talk about the physics point of view. So, work is done when a force is applied, and that force brings about change in the direction in which the force is applied. This is the definition of physics. Now, to explain this, let us take two examples. In one example, I made a rough diagram of it, that there is a man pushing against a solid wall. The force is applied in this direction. This man is applying the force in this direction, but the wall remains stationary. The man is not being able to move this wall in forward direction. In the second case, there is a lady pushing the pram in which there is a child. She is applying the force in this direction. and the pram is moving eastward. Do you think that both these uh, personnels are doing work? Well, in the first case, because there is no movement of the wall is stationary. So, from physics point of view, this person is not doing any work. While this lady is applying a force in the direction of the force, this frame is moving eastward. So, due to the very precise definition of the work, this lady is doing work, while this man is not doing any work. But if a common person is seeing that the man is pushing the wall to destroy it, so that person will think that he is doing much work, but he is not been able yet to destroy this wall. So in common way, we are saying that a person is doing work, but physics is not giving importance to that works in which there is no motion in the applied direction. This is also very important, ladies and gentlemen, that wherever you are applying the force and the movement is not in that direction, then the physics is not considering this force. Let me give you another example. For example, there is a person who is taking out on his head a heavy sack of cement, and he is going from this place and this place and then coming again to its original direction. He covered a long distance, but because from where he started he came back to this original position, so the displacement, I should say, is zero. So because W is equal to F force, he is applying the force, but in this case the displacement is, the distance is zero. He covered much distance, but from the initial position till the last position, the final position, he covered no distance. So zero will be here, and when zero is multiplied with anything, then that is equal to zero. Common man is observing that this person is doing a lot of work, but in physics we are saying that this person is not doing any work, and again I am telling you that is because that precise definition of the uh, work. Now what is work? Let us define it first. So to define a work, you have to see first this mathematical equation. What is work? F, force, S, direction, distance. But because F is a vector quantity, so it must have a direction. So you have to mention the direction of that as well. A work is the only quantity. Not only there are other, but work is the quantity which is scalar, but we are getting it from the multiplication of two vector quantities. Remember that force and displacements both are vector quantity. So when vector is multiplied by a vector, it yield work. This is important. Torque is a vector quantity. Torque is equal to F cross D. Distance is a scalar quantity. F is a vector quantity. So when scalar and vectors are multiplied together, they are giving you the vector quantity. So these are very amazing point of views of physics. So keep in mind that work done by a constant force is given by the product, because this is multiplication, the product of the force, the distance moved in the direction of the force. This direction of force is very important. In mathematical form, we can write W is equal to Fs, where W is work done. I am writing it. W is equal to work done. F is the force and S is the distance. S is the distance. So in this case, if he is covering a distance and coming back to its original position and somebody is seeing it, then the person will say, saw him that he started from here and again he is here. So it means that he not moved from its original position, and the distance between first initial and final position is called displacement. So displacement in this case is equal to 0. That is, the work done is 0. The SI unit of work is joule. Few people are calling it joule. Whatever it is, we don't have to be concerned about the pronunciation. This is another language term. So very technically, our teacher in the university told us that this is joule, not joule. But whatever you are pronouncing doesn't matter. Okay, what is joule? If you are defining that how much will be 1 joule, so you have to see first to this mathematical form. F is a force and S is a distance. So it means that if 1 Newton of force is applied and it produces a displacement of 1 meter, then the work is said to be 1 joule. 1 Newton force you are applying, there is a measuring instrument which is measure your applied force, and there is another instrument with you which is measuring the displacement covered due to that force. So if 1 Newton force is applied, the screen is showing 1 Newton and the other screen is showing 1 meter, then it means that you have applied only 1 joule of force. So from this you can define the force and you can also define the joule. Now, what is joule? The work done by a force. The work done by a force of 1 Newton which moves an object through a distance of 1 meter. So if it is moving through a distance of 1 meter, then we are saying that we have done 1 joule work with one exception, and that is very important, and I am explaining that in a moment. in the direction of the force. Again and again, I am telling you that you have to keep in mind the direction of the force. If it is not in that direction, you are not doing any work. Let me explain this with the help of two examples. There is a person who is holding a brick in his hands and he is moving in this direction. He is holding this brick against the force of gravity and he is applying this force in upward direction. He is applying this force in upward direction. And then he is moving at the same time as well. Movement is there, but wherever on the direction he is applying in upward direction and the brake is moving in the right direction. So according to this part of the joule which moves an object through a distance of 1 meter in the direction of force. He is applying the direction of force in upward direction, but the brake is moving eastward. So it means according to that precise definition, this person is not doing. He is doing zero work done. Let me give you another example. A girl holding a heavy pile of book and she is stationary. She is standing stationary for 1 hour. The common man will say that she did a lot of work. She is sweated. But physics is saying that she has not done any work. Why? Because she is keeping this heavy pile of books and applying a force in upward direction against the force of gravity, but because there is no movement of the objects in her hands in the applied force direction, so physics is saying that she has not done any of the work. Now, to explain this with a word example, I am taking it from the book. And that is on page number 81. And that is saying word example 6.1. Figure, there is a figure given. 6.5 shows a person pushing a trolley in a supermarket in the force exerted by him on the trolley is 30 Newton. So we have to write F is equal to 30 Newton. And this is work example 1 and given on page number 81. Then again, if the force F exerted by him on the trolley is 30 Newton and the trolley moves a distance of 5 meter. So we are writing S is equal to 5 meter. Then the question is saying, in the direction of the force, calculate the work done by the force on the trolley. So we have to find the work done. Now let us solve This problem remaining in the context of the mathematical form of the work is W is equal to Fs. So if we are putting the values, that is 30 and 5, and we are writing it 150 joules. So that will be the answer. That person is doing 150 joules of work. Simply you have to multiply force and the distance covered. One of them must be given to, two of them must be given to you. Both of them must be given to you. Then you will be able to solve this problem. There are three variables inside it. So if 2 is given, you can find the third one. If force is given and work done is given, you can find the distance. If the distance is given and work done is given, you can find the force. If force is given and distance is given, you can find the work done. So in this case, remember that joule can be also, because F is a Newton and that is a meter. So Newton meter with is also, you can say, which is torque as well, but here you can say Newton meter is joule. So you have to keep this in mind as well. When one joule, when 1 Newton of work is given and 1 meter of distance is covered, so work is said to be 1 joule. Remember this as well, and you can write 1 Newton meter as well in the direction of the applied force. Okay, now there is another part given, and that is work example 2, in which there is a table given, in which there is a table given, and I am making this table and the required data here. So there is a table, there is a ground, this is the ground, and there is a table. I am making the rough diagram of that table. There is a table, and the height of this table from the earth is given as 2 meter. Keep this in mind. And there is an object. Somebody has to raise it to the table, and he is applying a force of 10 Newton. A force of 10 Newton. This is object, this is ground, and this is table. Now this figure is given. I made it for your convenience. So let us now see what the question is saying. Figure shows an object being lifted from the floor onto a table top, which is 2 meters above the ground. If the lifting force is 10 Newton, calculate the work done by this force on the ground. So 2 meter is the height of the table and 10 Newton is the force. Nothing difficult is there. So here this is work example and 2, which is given on page number 81. Yes, it is, sorry, 82. It is page number 82. So F is given in this case, and that is a vector quantity. So we have to write it as this. And the height is given as 2 meter, because the person has to cover a distance of 2 meter to raise it from the ground to the top of the table. So we have to find that how much work that person has done. Now in this case we also know that as from the definition of the work, W is equal to Fs, and we have to put the values, that is 10 Newton and S is 2 meter, so it is 10 multiplied by 2, and Newton meter is equal to joule. So I am writing that is 20 joule is the answer. Now, in this case, you are applying a force in upward direction. And this is also moving in upward direction, so you have to consider it. If the person is stationary, but he is in the example I given you, although they were stationary, they were not pulling it upward. If they were pulling it upward, then there was work. But in this case, you are pulling it in this direction and the object is moving in that direction, so you don't have to consider it to be a zero. Now, these are the two work example, hopefully cleared your concept about the work. Tomorrow we will inshallah give the second concept, that is also very important, and that is the energy. So be in contact with this channel, Rahman Digital Production, and if you haven't subscribe it and also press the bell icon so that you will be the first person to inform when I upload a new video. Thank you very much for your time. Have a nice time. Allah Hafiz.